There we go.
Hello, everyone, and welcome back to another Fusion 360 live stream. I am your host for today, Jason Lichtman, and I'm a technical specialist for design and manufacturing focused on Fusion 360 here at Autodesk, based in Denver, by the way. Last live stream I did, it turned out that I was pretty camouflaged with the black wall behind me, so I thought it would be pretty fun. Instead, I'm going to be camouflaged with the Fusion logos that are also behind me today. Today's topic is going to be ECAD M-CAD, and it's a fun topic, so I hope you guys enjoy. MCAD is what you're already probably doing in Fusion 360. It's mechanical design. ECAD is going to be a little different. ECAD is electrical design. And this this live stream rather, is going to tell you a little bit about how those two can merge together. Keep in mind that it's not necessarily you designing both the mechanical design and the electrical. It could be you doing the mechanical design, but working with an electrical engineer who is doing the electrical for you. But remember, that's not just a one-way street. There's a collaboration between the electrical design and the mechanical design that has to happen. After all, you could get a circuit board from an electrical engineer, and when you start designing the mechanical enclosure, you might find that some of the electronic components are in positions that are less than ideal. And you might think that you're stuck with those positions, but in reality, you might be able to request that the electrical engineer change those for you and move things over to make it easier. And instead of being able to send that request via an image, with maybe a screenshot and some markup drawings to it, you can actually communicate that via Fusion 360. What you're going to require for doing this is going to be Fusion 360 itself, and then also Autodesk Eagle. And if you're not familiar with Eagle, it is a PCB design tool. So it designs the little circuit boards that you might find in most of your electronic products. Today, we're going to be talking about this guy. This is an air quality sensor that some of you may have received at Autodesk University last year, or Fusion 360 Academy in Portland just recently. And this air quality sensor is going to go and measure the quality of the air around it. So the air goes through this particular housing, then it has some sensors inside that are going to go and pull in that air and measure it. And then it's going to have some LEDs on the bottom to actually tell you what the results are. It's like a visual communication. And this is a great example of a product that has both mechanical parts, in this case, the enclosure itself, the stand, the screws that hold it all together. And then it also has electronics in it that are going to be doing some important functions as well. I'm going to use this example today, and I'm going to show you some of the different workflows that you can have between Fusion 360 itself and Autodesk Eagle. I hope you're excited. By the way, we have Brad Tallis on the keyboard, so if you have any questions, please feel free to ask them. Brad's going to do his best to answer those questions himself, and for anything that he might not know the answer to, hopefully I do, he'll make sure to let me know those questions, and I'll be able to answer them either live right now or later after the video is recorded. I'll answer those questions as well. Let's jump right into Fusion 360, and we're going to take a look at this particular assembly and what's inside it. As I mentioned, we do have our mechanical enclosure, and then we have our electronics. Actually, in this case, we don't have any electronics yet. We're going to go and design those and show how we can bring it into Fusion. I do have the Honeywell sensor that's actually going to do the bulk of the work, but I do need a PCB that's going to take that information from that Honeywell sensor and be able to output the lights, the LEDs. And the cool thing about this design, by the way, if you don't have one yourself, is that this involves a variety of different manufacturing processes. We have milling for the shell and for the top piece. We have laser cutting for some of the spacers. We have injection molded components, and then we also have 3D printed components all in one product. So this is a great example of all different kinds of manufacturing processes. The first step we're going to do here is turn off this really bright LED, and then we're going to start to jump in to design our PCB. I've already created a PCB component, but it's empty right now. So we're going to go and activate the component. It's going to gray out everything that it doesn't need, and we'll be able to define the PCB outline. Like what's the max size the PCB can take? If it's too big, it's obviously not going to fit in this particular product. So we want to make sure to define that. And instead of drawing something and then sending it over to the electrical engineer, I can actually do all of that inside Fusion. So the first workflow we're going to show you is how to design the PCB shape and then send that over to Eagle. Now that I have the PCB design, the component activated, I am going to go and create an offset plane on this face right here and say OK. And I'm going to go and create a sketch on that plane. And although it rotated my view normal to that sketch, you can turn that setting off if you don't like that, by the way. So what I'm going to do here is I'm going to project geometry from the existing design, and we'll use that as the basis for the PCB. So I'm going to use a shortcut. It's P for project, but you could also find it under Create, Project, and you'll see that right here under Project. You can project either specific entities or the entire body, whichever one you prefer. So I'm going to go and project an entire body, and I'm going to go and use this component, which is the 3D printed component, and it automatically creates the outline of that particular shape, which is perfect. Next thing I'm going to go and do is I want to define the max size. And so I'm going to go and grab the shell of this design, and I'm going to isolate the shell so I only see the shell. I'm going to repeat that again for anyone that might not know that trick. You can right-click on a component and say, I want to isolate it, and it will hide everything besides that component. Now that I see this, I'm going to want to make sure I grab the inner edge of the component. So I'll go back to my shortcut, P for project, If I were to select the body, it's going to give me a silhouette. So it's going to take the outer contour and the most inner one, and that's what's going to project for me. But what I really want is not the absolute smallest diameter, because there's a section of the top of this shape that's smaller than where the PCB is going to go. I really just want this inner edge. So we'll switch this over to specific entities, and I'll go and grab the entity that I care about and say OK. Now, it did just give me a warning in the bottom right corner that what I just created is invisible, and it's because it's part of the PCB component that I don't see right now because I isolated the shell. That's perfectly fine. We'll just go and unisolate the shell, and we'll actually hide the shell. I don't need it at this point. In fact, we don't need anything else. We'll go and isolate just the PCB now, and I can see just what I care about. What I do want to make sure I have is a little bit of clearance between that sketch that I just created, that's the inside of the shell, and the PCB itself. So I'll go and create this into a construction geometry, and I'm going to go and draw maybe an we'll just go and draw a quick circle here. I'm going to go and say I want these to be concentric using my constraints that I have, and I'm going to set this to be 1 millimeter in gap. Perfect. Next thing I'm going to go and do is I'm going to make a flat spot because we are going to need to bring in power for this PCB, and I know that the connector I'm going to use is going to need a flat spot. So I'll go and draw a quick line from left to right here. I like to intentionally draw lines crooked so that I can know that when I snap them to be horizontal, they're truly horizontal. But your preference. Another trick to that, we'll go and delete it and I'll do that again, is we're going to go and draw that line, and as long as I'm truly horizontal, you'll see there's a small blue icon that shows up below the line telling me that I'm going to snap to horizontal right now. That's perfect. Next thing we're going to do is add a dimension. I only need a 10 millimeter width on that, so I'll go and add that. And then we're going to go and trim this section here that I don't need anymore. That's perfect. So far we have a sketch for the outline. And we're going to go and say finish, and we're going to go and turn this into the PCB. For that, you're going to want to go and say create a PCB component. Sorry, not component, PCB feature in your feature tree or your timeline. If you don't see this PCB option, it might be that you haven't turned on your PCB features, right? Actually, let me show you how to do that before we go and create the PCB. If you go to your name in the top right corner and you choose preferences, you're going to see I have a whole lot of different preferences that are specific to me. And if I log into another computer using my account, I'll keep all those preferences. One of them here is the preview option. And under preview, you'll see a variety of different things you might need to turn on. And it turns out PCB is no longer in preview. Just learn that right now. Up until recently, you would have had a checkbox here to turn on for PCB. And if you didn't have that checked on, you wouldn't have the features I'm showing you. But with Fusion 360 having updates about every 6 weeks, it looks like I might have missed that little addition in the last update. And now it's no longer in preview. You don't have to check anything for that. So don't worry about this. You can ignore that entirely. But maybe you learned something in the process. So at this point, we're going to go and say create PCB. And I have a bunch of PCB specific choices here, operations and features. The one that I'm going to want is this create a PCB profile. So if I choose PCB profile, it's going to ask me what profile do I want to use. I'm going to go and select this geometry here for this particular project. And it's going to give me the circle shape that I want, but it's going to leave me 3 holes that are exactly the right shape for the geometry that's going to fit into. That's actually perfect. And I get to choose the thickness of the PCB, and if I want to flip it, it'll flip it up versus down, as whether it's extruding that PCB up from your sketch or it's extruding it down. We're going to go and extrude it up and say OK, and I have a nice green visual of the PCB itself. Now I can go and activate my entire assembly, and I could unisolate my PCB, and you can see the PCB with respect to the rest of the 3D model. And this is a great time to go and look, and you can see that I have the right amount of clearance around my standoffs that are going to be holding the PCB. And if I also show my shell and look at this from underneath, I could see I have just enough clearance that 1 mm that I made earlier, so that I can make sure that this is going to fit nicely. At this point, we can go and save our design because everything that we need to do in Fusion has already been done, or at least so far. And I'm going to give a description. I always recommend you add a description whenever you save your files. And that description this time is going to be made 3D PC, no, made PCB outline, something like that. It's going to switch over from version 53 in this case to version 54, and it's going to put that description in there as well. Now let's jump over to Eagle, the thing that you might not have had as much time spending in as Fusion. So here you're going to see I have the Autodesk Eagle control panel, and I'm going to go and create a new design from scratch in this case. By the way, feel free to explore that we have a lot of really cool stuff in here if you don't already know it. But in this case, we're going to start off by creating a new PCB schematic. It created in my other screens. Let me go and drag that over here. So now I see I have my schematic, and we're also going to go and say, let's go and switch over to the board layout. And now it's saying, hey, your board doesn't exist. Do you want to create a board that's linked to the schematic? Right? Because every PCB needs a board and a schematic, and they do need to be linked. So the software is smart enough to say, hey, you don't have the second one. If you want to create it, do you want to link it? Of course, yeah, let's go for it. So we created our schematic, or sorry, a board layout as well. And now you get to start to see the integration with Fusion 360. Over here on the right, you see this Fusion 360 icon. When I click it, it's going to connect to my Fusion 360 account. And at this point, it's going to ask me, do you want to link this new Eagle file that you just made to your existing file, or are you going to actually create a new one from it? Well, this workflow that I'm showing you right now, we started in Fusion. We already created something. So we're going to link this to an existing file. I'm going to go and click Next. And at this point, we're going to go and find that project. So we're going to go into my team hub that I have here, and we're going to find the one that says Fusion 360 Academy. I actually presented this class at Fusion 360 Academy. So if you were there, maybe you were lucky enough to be part of this class. Otherwise, you get to be a part of the class right here now in our live stream. We're going to go and find the file that we're working with. That's this air quality sensor without the board, because we're creating that board. And I'm going to link this to PCB 12. That's the PCB I just created in Fusion. When I click OK, it's going to let me pull the data from Fusion into Eagle. And it's going to show me the version description that I put in Fusion, so I can make sure that I'm grabbing the right version. And you could see the same description that I wrote in before, made PCB outline. That's where we're at right now. We're going to go and pull this data, and we have to wait about 20 seconds-ish, 20 seconds, for it to go and pull the data from Fusion into Eagle. At some point in a few minutes, we're going to go and create our PCB, and we're going to send it back to Fusion. That takes just a little bit longer. I would say about 30 seconds, but it's doing a whole lot more work. So no surprise, it takes a little bit. Here I have my outline. Let's go and grab this and move this into the right spot. It does look a little bit like a sad face, but don't worry, this is a fun project and we're all going to be happy. We're going to start off by adding our electronic components. So you can add your electronic components here in the board layout. You can also add it in your schematic. I've been told by quite a few electrical engineers that adding it to the schematic first is the preferred method. For full disclosure, I'm a mechanical engineer by background, not an electrical engineer. There was a time in university that I was considering double majoring in both, but it turns out that was too much even for me. So I'm a mechanical engineer. I don't do electronic design, but I'm still going to show you the basics of how you could do that in Eagle. For all of you Eagle specialists out there, if I make a mistake in Eagle, that's why. So please don't hold me too accountable for being a professional Eagle user, because I'm not. But I'll still be able to show you how to do the basics. We'll jump back over to the schematic, and we're going to go add our components. And to make my life easier, I'm going to use what we call blocks. And blocks are really a group of components together. So here I have my add a design block. We're going to go into the design blocks from my library, and we're going to start off by adding our LEDs. I'm going to hit OK and pull in, let's zoom out a little bit, pull in my schematic, and now I can see it here in Eagle. If I right click, it'll actually rotate the like the actual components. So I'm looking at this right now and I'm thinking this is rotated a little wrong. Let's keep clicking that again. And this is what I wanted. And another trick is that if you hold Alt, you get a little bit of a smoother manipulation of moving those components so you can get them in exactly the right spot. If you don't hold Alt, you'll see that it's like snapping to a grid. And depending on the grid size, you might not get the components where you want. So I'm going to hold Alt and move this into position. And this is about right. This is close enough at least. And we'll go and drop that in and hit OK. There I have my LEDs. We're going to go back to, actually, let's move these out of the way because I think they're going to be a little bit of a problem. Let's move them. And then we're going to go back to the schematic, and we're also going to add another block. This block is going to be for the main board. And I'll go and put that over here. And here I have the main board itself. Again, I can right-click and rotate this until it's something that I'm happy with. But I'm going to go and move this about here. And I think that's pretty good. And I could see this component is definitely in the wrong spot. So let's go and move that as well. And this is looking pretty good. Now, here's the reason that Fusion and Eagle are playing so nice together, right? What I'm about to show you, why you want to be able to do this. I can look as an electrical engineer over at this board, and I could see some clear problems. Like I see that this particular component is interfering slightly with the holes, right? They're too close. And I could maybe move those a little bit so that they don't interfere. And I could see that now I'm running into a little bit of a problem here, so I can move those over too. But what I don't see at this point is how they're going to interact with parts of the enclosure that matter. So like where the power is going to come from or where the cutouts are going to be able to access power switches or anything else. So I'm kind of shooting from the hip and I don't really know how this is going to work. So whatever I send over to the mechanical engineer is likely to come back to me with markups and drawings telling me that there's some sort of problem. And instead of having to worry about that, let's actually switch back over to this camera. There we go. Instead of having to worry about that, I can do my best job as the electrical engineer here and then fix everything in Fusion where you can see all of the visuals of the 3D models. Remember that the electronic components, they have a thickness as well, right? There's a height to all of them. And I don't see that in Eagle either. All I see is a 2D bird's eye view of the layout, not the thickness. So being able to see that in 3D and being able to fix that is a good thing. You're going to want that. So let's go back into Eagle. Here I could see I set everything up to the best of my current ability. And we're going to go, oh, we have one more component to add. That's going to be the power. So let's go and add another component. We're going to go right over here to add another component. And we're going to go and find this from my library. And we're going to go and look for a micro USB component. This is taking, oh, there we go. I was going to say a little longer than I would have liked, but there it is. So we're going to go and find my micro USB. And I'm going to go and grab this guy. I did make a mistake already. I like to tell people that I'm human. I make mistakes. It happens from time to time. If you ask my wife, she'll tell you it happens more often than she'd like. But yes, I do make mistakes. We're going to go back to that schematic. We're going to go and put the component in the schematic first. So let's go back over to the schematic, do the same thing. We'll go and add our micro USB. Go and scroll down over here, find our micro USB, go and grab that, put it into my schematic, and then we'll jump back over to the board. And here I have my component. So now at this point, we can go and move this into place. Let's go back a bit. Remember that flat spot that I created earlier? This is why I created it. We're going to go and want to put this on that flat spot. And it's actually telling me here that this is going to be, this white spot here is where the edge of the PCB is supposed to be. So let's go and take this component and we'll rotate it around. Then we'll go and, oh, and by the way, I just used the rotate tool here in Eagle. And then I'll go and use the move tool, grab the very center here, and I'll move this into position. And again, that snapping feature is limiting like where I can move it. So I'll hold Alt, and now I can go and put this in a better location. That's much better. Okay, so now I want to go and see this in 3D. I want to go and bring this over to Fusion and see if I did a good job. So I'm going to go and check this Fusion 360 box that we saw earlier. And at this point, we're going to push this to Fusion. I say, let's push this to Fusion. It's going to check that it has a 3D model for each of the components that you're using in this design. And you'll see that I have it for most of them. There are a couple that I didn't already link. We'll talk about linking components like 3D models with Eagle in just a little bit, but you can see that most of them are already associated and linked. Some of them in this case are not. We're going to say first attempt at 3D. Crossing my fingers. And we're going to go and push this over to Fusion. As I said earlier, this takes about 20 to 30 seconds. It takes a little longer when you go from Eagle over to Fusion. And the reason is because it's taking the 3D model for each of those components, bringing them all together, and putting them in all the right positions based on this 2D schematic of an assembly. It's also going to go and do the same thing for the board itself, and it's creating decals for all of the traces. Now, for all of you Eagle users out there, you're probably going to say, well, Jason, you didn't create any traces. This isn't going to work without traces. There's nothing connecting all of those components together. And I would tell you, you're right. You got me. But here's the thing. If you know you're going to end up having to move those components, you also know that the traces you might make are likely to have to be ripped up and recreated. So in this case, what I like to do is I like to go and put the components in the PCB, send it over to Fusion and be able to see what the results are, be able to move those components wherever I think they need to be, send it back over to Eagle in the new positions, and then do our tracing. And we'll go and cover that in just a little. Here I have a pop-up, and it tells me that the Eagle board has been successfully pushed to Fusion. We're going to go and say, okay, close this out, and let's jump back over to Fusion itself. One thing that you are going to have to do, and it's unfortunate, hopefully we're going to go and fix this, but right now you do need to close your Fusion design, because even though I'm looking at version 54, if I go to my data panel, it's going to say that the data has been updated. If I refresh it, you're going to see that there's actually version 55 that exists. So I'm going to close version 54. I'm going to open up version 55. And now I'm going to see the 3D model of that board, which is the really fun stuff. Takes just a second for that to load. We'll close our data panel. And at the moment, everything looks exactly the same as I would expect. Let me go and make one little quick trick here. I'm going to go and hide something that I'll show you in just a little bit. So if you're curious what I hid, don't worry, I'm going to show you that. But we're going to go and hide the shell. This is something I want you to see. And now you're going to go and see that I have a PCB in here with all of the information in it that I described. I have the thickness of the board. Well, we already had that, but I also have all of those components. I have my 4-pin connectors and my 16-pin connectors or 32-pin connectors. I have my microcontrollers and all of that good stuff. Of course, also my USB. I have my LEDs in here too. At this point, I can start to go and look around and see if I have any problems. And I can look underneath and I can look above, and I'm already seeing a problem. Let's go back and look at that 4-pin connector, the one that you see right here, and we'll go and look at it in Eagle. In Eagle, it actually looks fine. It looks like it's in more or less the right position, but what I'm not paying attention to is that the color in Eagle will represent whether the component is underneath the board or on top of the board. And it looks like I made a mistake, and I didn't have that 4-pin connector underneath where it's supposed to be. Right now, I would have no way whatsoever to connect my ribbon cable to that 4-pin connector. So the cool thing is that instead of having to go and do Alt print screen, open up maybe Paint, which doesn't happen to be the best drawing program ever, but you can bring up Paint and you could paste in that picture and you can start to draw, hey, electrical engineer, we have a problem here. I need you to move this, right? Please move this to underside, something like that, and send it to the electrical engineer in an email. Yes, the electrical engineer can get that email and of course flip this to the underside and we can get a new Fusion model, but it's not just about the fact that the 4-pin connector is on the wrong side, it's also in the wrong position because it's going to end up needing to be seen through this digital I/O port here. That's where I'm going to connect it. And so let's go and start off and show you how you can make these changes in Fusion. We're going to go and edit the PCB feature that I made earlier. Now that I'm in here, I can see all of my PCB tools, including that board profile that we made earlier. But now we're also going to look at these: move PCB components and flip component. Those are the two that I use the most. We're going to say, let's flip this component to the underside and say, okay, nice. Now I have it underneath. But you could see that, as I mentioned earlier, this is lined up very incorrectly. I could then go and say, let's move this component. And at this point, I can go and rotate it 90 degrees. And then I can also go and move this until it's lined up correctly in the center of that square. And now we're talking, right? This is exactly what I wanted. I could never have really seen that easily on the Eagle side of things, but yet I see it here in Fusion very well. At this point, we're going to go and look that I actually created some other problems for myself. I actually now have an interference between that 4-pin connector and my other components. And so I can come in here and move these components wherever they need to be so that I'm not going to end up having any interferences. Maybe I look here and I say, even though Eagle said that I had just enough room for those connectors there, maybe in real life it's not going to work because I didn't see this component from above. Well, I can go and move that as well, and we'll move that over maybe a millimeter. Cool. Now you guys are probably noticing that the holes in the board for those components didn't update, right? That's actually a function of Eagle, not on the Fusion side. So at this point, although I made all my Fusion models, like I moved them around to where they need to be, I still need to send this to Eagle so that it's going to see those updates, and I can make my traces and all of those kinds of things. Then I could send it back over to Fusion and everything will be perfect. So let's go and take a quick double check to make sure I don't need to move anything else. Oh, I do actually. We're going to go and move this component and we'll move that over there. That's looking pretty good. Everything else is pretty good. Maybe we'll move this guy as well. And we'll move that over 2 millimeters. Perfect. Now I'm done, at least for now. So we finished the PCB feature. We're going to go and say save this, and we're going to go and put our description, moved components to match physical model. Or no, we're going to say to eliminate. I clearly have trouble spelling during live streams. To eliminate interferences. Perfect. So let's go and do that. It's going to go and up the version on this from 55 to 56 at this point. And then we'll be able, because we know we're going to have to reopen the file in Fusion, we can just go and close this in Fusion already. Let's jump back over to Eagle. And here's the cool thing in Eagle, that I already see a red color around this Fusion 360 button. It already knows that there's a newer version from Fusion that I'm probably going to want to pull into Eagle. So let's go and click this button here, and we're going to say, let's pull this from Fusion. I see the updated description that I just put in, spelled correctly, I think, which is good. And we'll go and pull that from Fusion over to Eagle. And I want to move this window out of the way because what you're going to see here in the center of the screen is all those components are now going to move into the correct locations based on the physical limitations that I have on the board. This is looking great. That's exactly what I wanted. And now I can start to go and add my traces. Now you can add those traces manually, and I'll say from what I've learned that most electrical engineers do trace everything manually. But if you want at least a jump start so you could do less manual tracing, we do have some auto routing options here in Eagle. So auto routing is going to connect everything that needs to be connected automatically, to automatically route. And by the way, if you're curious about what's going to be connected, everything here that's yellow lines are going to connect to each other. Because in the schematic, if we go back here, this is telling you what needs to connect to what, right? So RB7 on that component is going to connect to here, to this terminal on this connector, and then to that terminal on this other component. So we know that in Eagle, and so we're going to go and connect those for you. Let's go to the auto route. And we're going to go and say continue. It's going to go and figure out not just one routing option for you, but multiple. And that's really cool because each electrical engineer might have different preferences of the routing, both from a functional standpoint of like the quickest. Oh, I have to hit the start button. Let's click the start button. So some people have preferences both on the length of the routing, but then also the visuals of what the routing looks like. Some people care about that as well. So here I have 5 different routes. I can select, the top one is more often than not the best one, but it's not always the case. You can select each of these and see what the result looks like. And then when you're happy with one of them, choose to approve that, and it's going to go and use it. We're going to go and actually we'll go with option number 2, let's say end job. This is the routing. If I want to change this, I could always go and rip up, or it's the equivalent of like delete in Fusion, rip up one of these routes and then reroute it manually. Once I'm happy with the final result, we're going to go and push this back to Fusion for one last time. We're going to go and say push this to Fusion. Everything is ready for the ME, which is short for mechanical engineering. We're going to go and say push. Again, this is going to take about 30 seconds. It's the same issue as before. Take all of those components, merge them together in the right locations. But also now we have a little bit more work to do, because we're going to take the traces and turn those into like a decal in Fusion, so you can actually see what the board's really going to look like. And that might be helpful to you if you're going to end up making renderings of your design and be able to put those on your website or anywhere else that might matter to you. So our push, or our synchronization to Fusion, is about to finish. We're going to get that pop up in just a second, and now we know it's done and ready to go. We're going to switch back over to Fusion 360, check our data panel. Of course, we have a refresh here. We're going to see version 57. Everything is ready for the ME. And remember, I happen to be doing both right now. I happen to be using Eagle and Fusion myself, but you can have the electrical engineer who happens to have Eagle and doesn't have Fusion, and this will still work. As long as you, as the Fusion 360 user, invite the Eagle user to your project, then the Eagle user is going to be able to see that project in Fusion on their Eagle side. Well, that was confusing. Let me say that again. The Eagle user is going to be able to connect to the Fusion 360 files through Eagle and be able to push those 3D models. Now you might, by the way, just as a little future heads up, you might want to have Fusion 360 even as the electrical engineer, because you'll be able to make 3D models of your custom components and be able to use those 3D models so that when you push it to Fusion, it'll come in with the right 3D model. So there are benefits of having both, but you don't need Fusion. So if you are just going to do the Eagle stuff, that's totally fine too. Let's go and open this file. And we're going to see at this point, not just the board, but we're going to see the board with the new positions, with the holes matching those new positions. And we're also seeing the traces. Let's go and zoom in and close our data panel. You're seeing the traces of all the electrical wiring as well. Pretty cool. I love this. It just makes the back and forth way easier between myself as the mechanical engineer and my electrical engineering counterpart. So now that I have this, what's left? Well, now I can go and finish designing the enclosure to make sure that this is going to work for me, right? I have everything underneath lining up. I have this lining up. And now I'm seeing for my nearly first time this electronic, like the power cable here. This is going to be a micro USB controller, and I want to make sure that I can connect to it. And if I show my shell, I see a problem. Any of you guys see it out there? If you do, type it into the chat window. I'll give you about 5 seconds before I go and I tell everyone what the problem is. And there, 5 seconds are up. So the problem is that you can't actually plug anything in because I don't have a hole in the shell. Now, we can do this manually, and I'm going to show you the manual method, and then I'll show you the really slick method that I learned from Kevin Schneider. And if you don't know who Kevin Schneider is, he is, I'll just be direct, he's a complete badass. He is awesome. He is called within Autodesk the godfather of Fusion 360. He was one of the people that first helped create Fusion from nothing. he knows everything. And I wish sometimes that I could just like run around in his brain and just soak up his knowledge. This is just one tip that you're going to learn from me that's really his tip. First, let's do it the manual way so you can see how awesome that is. We're going to go and edit the shell. And at this point, we can go and look at the origin and the coordinate system for the shell. And I can go and grab, let's say, a plane like this, and I can hide the body of the shell, see everything that's inside, and we'll go and rotate maybe to the other side. No, we were actually in the right place. There we go. And now that I could barely see it, but it's here, I can come in and draw a rectangle and make this the right size for my USB connector. Maybe it happens to be 12.5 millimeters by, I don't know, 8 millimeters. And then I can also go and project geometry from the actual like plug. And so I can come in here and project the plug itself. And now that I see that, I could even actually probably hide everything I do. Let's go and isolate our shell. And I can also go and add dimensions from different areas of the plug to make sure that this is going to fit right. So maybe this is going to need to be an extra 2 millimeters, or I could center this, of course. I could even change the dimensions here. We'll make that a driven dimension. So now I could also put a dimension from maybe the bottom of this micro USB plug. And something's a little funny there. Let's try that again. I'll use a point this time. Much better. And we'll go and make that 2 millimeters as well. So I could take this shape, maybe add some fillets to it, and then I can go and extrude that through the shell. And I'll leave this as is. This doesn't have to be perfect for now. It's really just showing you the point here. And if I show my body, I could take this extrusion, let's select this whole thing. I could take this and extrude it through my shell, like this. Now you're probably thinking to yourself, okay, Jason didn't do all the detail work, and that's fine. But you can figure out what those details are going to be and then, of course, do this. But if you're using the same kind of plugs, like micro USB plugs or full-size USB plugs or whatever it happens to be for you, you're probably going to end up doing this over and over and over again, which is a waste of everyone's time. We want to use automation to be able to help us to make our life easier. So the trick that I'm going to show you, the Kevin Schneider trick, is as follows. You can create a 3D model. Let me actually delete all this stuff that I did so we could show you the better way. There we go. So you can create a 3D model for anything you want. You can create the 3D model both for the actual plug, like the receiver, the female in this case, or you can create the 3D model for the male part as well. So if, for example, I go and I say, I want to take a 3D model of this plug. Maybe I already created it. Maybe I downloaded this from a website like GrabCAD or something like that. I bring in this plug, and I can actually use my assembly features in Fusion to align this correctly. So let's go and do that. Actually, hold on. I made another mistake. I had the shell activated when I brought in the micro USB plug, so it's coming in as a subassembly of the shell. That's not what I want. I'm going to go and delete that. We'll activate the assembly this time. We'll go and bring in that same plug. And this time, the plug itself is going to come in at the assembly level. If you don't want to go and delete that and bring it in again, you could also drag it into the assembly level, and it'll just create a new feature that moves that component from the shell component into the assembly. I hope that wasn't too confusing, but you can actually drag components into other components and make sub-assemblies anytime you want. It's amazing. Let's go and undo that too. So here I have my micro USB plug. I'm going to hide the shell, and I'm going to go and make a joint between the plug itself. We'll go and use the origin of the plug to the receiver, the receptacle. And I have that as part of the PCB component. We'll go and scroll down, and I see, where was it? This guy, I believe. We're going to go and grab the origin here. And my plug is going to show up in closely, almost the right spot. I do want to do the flip command here and make sure this is set to 0. And now it's in the right spot. So here's the first part of the trick. You can create a 3D model of your male plug in this case, use joints to put in the right place. And then now that you've done that, you can go and show the shell. Maybe we'll actually activate the shell. and I can use the combine command and say my target is the shell itself, the tool is the plug, and I want to do a cut. And we can use that to get a perfect recess for the plug. This is actually great. This is awesome. Let's go and hide the plug itself. And now you can see I have a perfect recess for that plug. Now the challenge is that there is no tolerance, like no gap between the parts at this point. They are like a perfect fit. You can solve that pretty easily by changing the 3D model of the male plug and adding your own offset to it. Right? You can add an extra gap. You can reduce the detail because it's doing a little bit of funny stuff here because of the way the plug was designed. And it's like creating extra bodies for pretty much no reason. So what you might want to do is you can go into that model and you can edit it however you want, parametrically or even using direct editing to simplify the model. So let me show you the one that I created, and then comes Kevin's trick. This actually isn't Kevin's trick. So here I have that same plug, and now I'm going to show you what it looks like when I start to simplify. I have a body here. Oh, I have to scroll back in time a little bit. There we go. I have a body here. I made it red so it's easier for everyone to see, but this red body is the simplification. So I got rid of all of, let's see which one. This guy. Okay, I got rid of like the USB indent here, that recess with all the detail. I got rid of all this detail here of those grooves. And then I also added some offset so I can make sure I always have enough space. Because after all, if you look at plugs and connectors, some of them are different, whether you buy them on eBay or Amazon, or you got it from China or in the US, the Apple Store, they're all going to be slightly different. So you might want to create your simplified model to match any plug. No matter what one you use, it's always going to work. So the trick that Kevin taught me is that you can actually override your 3D models into Eagle. So if you design something in Fusion, all you have to do is save it as a step model. And then on the Eagle side, you could say this micro USB connector actually has a more interesting 3D model than the stock one. And it's going to include the red cutter as well. Let me actually, better. Okay, so here you could see this is the connector that showed up in Fusion. Right, when I used that connector in Eagle and I sent it to Fusion, it uses this shape. But what I'm going to do is I'm going to replace the 3D model for this female connector with one that has this plus the red shape. So do you guys remember when I first brought in that PCB, I hid something and I did it like real sneaky so you guys didn't see it? I did it because I just didn't want to complicate things at that time. I want to be able to show you all the basic stuff and then get into some of the more advanced stuff like this. So let me go back and show you what I hid. Let's actually also delete this feature, this combine feature, because we're going to do it a different way now. So let's go and hide we already hid actually, our micro USB male plug. Let's also go and hide the shell for a second. Let's also activate the assembly so everything is nice and opaque. And let's zoom into that same micro USB female plug. If we go and look at our PCB itself, I can scroll down and you can see there's a component for each of these electronic components. You can click on these and they'll highlight in the 3D model. One of these happens to be the 3D model of this micro USB plug. And you'll see here under the bodies folder, I have a bunch of different bodies. Right now, we're showing the two that matter for like plugging something in. That happens to be body 2 and body 3. Right, and I could hide those two if I really want to. But the cool part is this body 4. Body 4 is that red connector, right? That keep out zone that I designed in Fusion myself and saved as a step model, and then went into Eagle and I replaced the 3D model for that component using this. And I'll cover in a minute how to actually do that replacement, but I already did that. So now that I've done that, this red component is in here, and now I can go in and show my shell, activate the shell component, and instead of doing the combine cut using that plug, I'm actually going to use the cutter that I created. And the best part about this is that this came in not with the male plug that I use joints to be able to get into place. This came in automatically with the electronic component for the female receiver of the plug. That's the cool. Now I can go and say, yes, I want to cut this. I now have, let's go and hide that component again, the body again. Now I have a perfect cutout, and this is going to work for all plugs, regardless of what kind of plug you're using. And here's the real kicker. If you decide to go into that PCB editing feature here, and you say, hey, I actually need to move this somewhere else, it's going to move not just the 3D model of the female receiver, it's also moving, you could sort of see that in like the blue shadowy thing. You can see that it's moving the keep out zone too. And now when you exit out of this PCB tool, it's also going to recreate that cut in the new position. After all, Fusion 360 is a parametric modeling tool, so anything that you do earlier in the timeline will update later. So that combined cut will also update using that new position, which is really awesome. Thank you, Kevin Schneider, for that tip. I use that tip all the time, and I hope that you like that tip and that you'll use that tool. That too is what I meant. So this is a great way for you to be able to have your cutter or your keep out zone, whatever you want to call it, and it will update based on the position of the 3D model. Whether you choose to move that 3D model in Fusion using the PCB edit commands, or even in Eagle, I could go back to Eagle, move that PCB component, and then push it back to Fusion, and then Fusion will see that, and then the combined cut will also update. Same result. Either one is perfectly fine. So this was really just a quick taste of what you could do between Fusion and Eagle. There's a lot of really cool stuff there, and this is really just the tip of the iceberg. And by the way, this is going to get better and better over time. Fusion 360 is committed to making different tasks from different people, right? From industrial designers to mechanical engineers to machinists, all integrated into one tool to make that better and better. And PCB is not going to be any different. So we want to make that collaboration between electrical engineers and mechanical engineers better and better. If any of you have been to the Fusion 360 Academy, you would have seen a taste of what's to come, but this is going to get better and better, and I can't wait for you all to see that. One thing I forgot to tell you is how to actually replace that 3D model in Eagle. Remember I told you earlier that I'm not a super professional Eagle user. I'm not going to go and demonstrate that for you because I'm going to mess it up. But I will show you where you can go and find that. And I'll also update the links in the description of this video so you could actually see that as well. So I'm actually just opening up a web browser here. We're going to go to YouTube, which you all know how to get to because you're watching me live right now on YouTube. But we're going to go to YouTube, and instead of going to the Fusion 360 channel, we'll go to the Autodesk Eagle channel, Autodesk Eagle here. And if you go into this Autodesk Eagle channel, you'll find a lot of really good videos, many of which cover exactly the same kind of thing that I'm showing. The collaboration between Eagle users and Fusion users, and some of the other workflows that I didn't even cover today that you could also do in Eagle and Fusion. But if you go in here, you'll find that there are a lot of videos, and a couple of these are actually step-by-step instructions to bring that Eagle and MCAD collaboration together. So here you can see ECAD to MCAD unification. And what you're going to see here is learn how to map step models to your packages in Eagle. This video, which has 11,000 views currently, is a perfect video for you to see exactly how to do it. So this is a great step-by-step instruction video. It's going to be way better than I could do live. This one was nice and edited to be super clean. So just go and watch this video and it'll tell you exactly how to do it. And don't forget that there are other videos here as well that are really going to help you, including this video here, step 1 for ECAD to MCAD is bringing in your importing your board outline exactly like I showed you. There's also a step 2 and a step 3 and a step 4. Those are all fantastic videos. Please watch those. And again, I will put links to them in the description after we're done here. I'm going to do a quick check on our questions from the audience to see if anyone has any questions I might be able to answer live. If you do, this is a perfect time to ask your question. And I don't see any. So we're going to go and end today's live demonstration. If I didn't answer all of your questions, I can go ahead and do that later as well. But for now, let's actually jump right. Oh, 1 second. There we go. For now, I just want to say it is my pleasure to make these videos. I hope you guys enjoy them. Please give us feedback on what other kinds of videos would matter to you that you want to see. We're happy to make content that we don't come up with ideas ourselves. That's okay too. So let us know what you think about these videos. Make sure to subscribe to our channel. If you do not already use Fusion 360, make sure to subscribe to Fusion 360. If you'd like to use Eagle, subscribe to Eagle. But no matter what, whether you have a subscription or not, I hope you go out there and you make incredible things. Don't forget that at Autodesk, we're all about making incredible things, and we hope you go out and make things. Have a great day. Jason Lichtman, signing off.